Every time you log into a website, you send your password across the internet. But here's the scary part. That data doesn't travel directly to the website. It passes through multiple computers, networks, and routers before reaching the server. So why doesn't someone just steal it along the way? Why can't hackers simply read your password while it's traveling across the internet? The answer is something called HTTPS, and behind that tiny lock icon in your browser is a fascinating system of encryption, digital certificates, and secure key exchanges. In this video, I'll show you exactly how HTTPS works step by step in simple terms anyone can understand.
Before we understand HTTPS, we need to understand HTTP. HTTP stands for Hypertext Transfer Protocol. It's the basic protocol that allows your web browser and the web server to communicate. Whenever you type a website address into your browser sends an HTTP request to the server. The server then responds with the web page you asked for. This system works very well for transferring information across the web, but there's one big problem. HTTP sends data in plain text. That means the information is not encrypted or hidden in any way. If someone intercepts that data, they can easily read it.
Imagine sending a postcard through the mail. Anyone who handles that postcard along the way can read the message written on it. HTTP works in a similar way. Because the data is sent in plain text, anyone monitoring the network can potentially see it. For example, if you are connected to a public Wi-Fi network at a coffee shop or airport, a malicious actor on the same network might be able to intercept your traffic. This type of attack is often called a man-in-the-middle attack. In this situation, someone secretly sits between you and the website you're communicating with. They can see everything being sent and received. This is why sending sensitive information over plain HTTP is extremely risky. This is where HTTPS comes in. HTTPS stands for Hypertext Transfer Protocol Secure. It's essentially the same protocol as HTTP, but with one major difference: encryption. Encryption transforms readable data into an encoded format that cannot be understood without the proper key. So even if someone intercepts the data, they won't be able to read it. For example, instead of sending your password as plain text, the data becomes a scrambled sequence of characters. Only the intended server has the ability to decode that information. This means the communication between your browser and the website becomes private and secure. To understand encryption, think of it like sending a locked box. You place your message inside the box and lock it before sending it. Anyone can see the box while it's traveling, but they can't open it. Only the person who has the key can unlock it and read the message. Encryption works in a similar way. Your browser locks the data before sending it across the internet. When the data reaches the server unlocks it using a secret key. This ensures that the information remains protected while it travels across multiple networks. HTTPS uses a powerful concept called public key cryptography. In this system, there are two keys. The first one is called the public key, and the second one is the private key. The public key can be shared with anyone, but the private key must be kept secret by the server. Here's how it works. The server provides its public key to your browser. Your browser then uses that public key to encrypt the data it wants to send. Once the data is encrypted, it can only be decrypted using the private key. Since only the server has the private key, only the server can read the message. Even if someone intercepts the encrypted data, they cannot decrypt it without the private key. Before encrypted communication can begin, your browser and the server need to establish a secure connection. They need to agree on how they will encrypt and decrypt the data.
This process happens automatically every time you visit a secure website. It involves exchanging information, verifying identities, and setting up encryption keys. This entire process happens in just a fraction of a second, and most users never even notice it happening. The process that creates the secure connection is known as the TLS handshake.
TLS stands for Transport Layer Security. It is the modern protocol that powers HTTPS encryption. During the TLS handshake, several important steps happen. First, your browser connects to the server and requests a secure connection. Next, the server sends its digital certificate along with its public key. Your browser then checks whether the certificate is valid and trusted. If the certificate is verified successfully, the browser and server agree on a shared encryption key. Once that shared key is created, both sides can begin sending encrypted data to each other. All of this happens incredibly quickly, usually in less than a second.
Interestingly, public key encryption is not used for the entire communication. This is because public key encryption is relatively slow. Instead, it is mainly used during the handshake to securely create something called a session key. A session key is a shared secret used by both the browser and the server. Once this key is established, both sides switch to a faster encryption method called symmetric encryption. In symmetric encryption, the same key is used to both encrypt and decrypt the data. This approach provides strong security while also keeping communication fast and efficient.
Now, you might be wondering something important. How does your browser know that it's really talking to the correct website? What prevents an attacker from pretending to be the server? This is where SSL or TLS certificates come into play. A certificate acts like a digital identity card for a website. It confirms that the website truly belongs to the organization it claims to represent. Certificates are issued by trusted organizations called certificate authorities, often abbreviated as CAs. Your browser already contains a list of trusted certificate authorities. If a website presents a certificate from a trusted authority, the browser accepts it and establishes the secure connection.
HTTPS is essential for keeping the modern internet safe. Without encryption, sensitive data could easily be stolen or manipulated. HTTPS protects things like login credentials, financial information, personal messages, and browsing activity. It also helps prevent attackers from modifying the data being transmitted between users and websites. Because of these benefits, HTTPS has become the standard for nearly all major websites today. In fact, modern browsers will warn you if you try to visit a site that still uses plain HTTP.
Let's quickly compare HTTP and HTTPS. HTTP sends data in plain text, which means it can potentially be intercepted and read. HTTPS encrypts the data, making it unreadable to anyone who doesn't have the proper key. HTTP does not verify the identity of the server. HTTPS uses certificates to confirm that the website is authentic. In simple terms, HTTP is like sending a postcard, while HTTPS is like sending a sealed, locked package.
Now, the next time you see that little lock icon in your browser, you'll know exactly what's happening behind the scenes. If you enjoyed this video, hit like and subscribe for more simple explanations of complex tech topics. And if you're curious about what happens the moment you type a URL into your browser, check out the next video on the channel where I break that down step by step. Thanks for watching.